Welcome. Here, the problem, there are actually three circles within a rectangle. And let's say this is a rectangle of PQ and RS. And within this rectangle, there are three circles. The very first, the larger one, have got the diameter of 6 unit, and afterward, second one is 4 unit of diameter, and the last one, if it is 2 unit, then there is a big problem we already described in our previous video. Please check my another video which is also given in the description box. So in that lecture or session where the diameter was actually 2, in that case we haven't got the solution, and please check that video, it's very important. And isosceles triangle, and why this three circle have got different diameter within the rectangle. This diameter and radius is very important, and of course their unit, the large one 6, then 4, then 3, why not here 2? Anyways, let's jump to solve this problem. Anyways, here very important thing is, within this diagram we consider that 100% not through the scale. It means that the diameter might be not 6 unit, which is fit within the rectangle, same as the second one and the third one respectively. So solving this problem, what we have to do, what we can do, so the very first circle, let's consider this is M, and this one, let's say N, and this one, let's say O. Now very first task is to add these two center, it means M and N, right? So from M up to this tangent or the touch point is 3, because the diameter of the large circle is 6. So in that case, of course, the radius is 3 and this one is 4. It means this length will be 2. So our main goal is to determine the length of AB. Indeed, we have to determine the length up to this much. So this length is actually a part of AB length, right? So if we can determine the length M to, let's say here another point, let's say C point, right? So MC is equal and parallel to BC prime, and which is actually our one of the important goal to determine CV prime. And of course this MC is parallel to PQ. Indeed, C point is right angle, and of course the triangle MCN is a right angle triangle, and here MN is 5 and MC, let's say this is the part is X, this is X. And now what we have to determine, CN or NC. So from C to this length, or from M to this point, same length, right? And this is the radius of the larger circle, which is actually 3 unit. So C and let's consider this is a point, say W. So CW is equals to 3 unit. What is our target? Our target is to determine CN. So CN is equals to CW minus NW. So CW is 3 and NW is the radius of this circle, which is actually 2, right? So NW is 2. So Cn is equals to 1 unit, right? So up to this length is 1 unit. So the red line up to this length, Mn is 5 and Cm is x and Nc is 1. So we can write down triangle MCN. So this is a right angle. So M n square equals to Cm square plus Cn square. So what is our target? To determine Cm square, right? So Cm square equals to Mn square minus Cn square. So Mn is 5, this 5 whole square minus Cn is 1 square. So it will be 24, right? And Cm is x square. So x equals to plus minus square root of 24. And of course, Cm is the length of something. So negative should not be accepted. So we can say x is equals to square root of 24, the positive value, of course. So this point M and C, which is x, so from B to this one we consider C prime. So this is x, which is the value of square root of 24. Now our main objectives is to determine the value of AC prime, right? Indeed, what we have to do in this step, we can add this to length, I mean the middle circle and the smaller circle center point, right? And as our main target right now to determine AC prime, indeed what we have to do, we have to draw a parallel line of AB, or we can say exactly similar to AC prime and AC prime and the parallel as well. So this line, let's consider this line the red line. This red line, by the way, we have to determine, and let's consider this red line is y unit. So this is our main target right now. And now if we can determine the length of y, how? If we can generate a right angle triangle, obviously this is a parallel line, so obviously if we extend this line, then we can determine the value of y, right? Now we know this red line right now, black one, is 2 unit, right? So this is 2. This is 2. The radius of this circle, this 2. And of course, from this point to this point, and this is N point, and this is O. So ON is equals to, so up to this radius is 2, and this one is 1.5. So ON is equals to 3.5. So this is 3.5. And now our main objective is to determine this length. This length, which is very important right now, right? So for this one, the total length from here to here is 6 unit. So up to this length is 6, right? And the diameter of this circle is, let's say, this length, right? Which is, let's change the color to as we can easily understand. This is the diameter of the middle size circle. So this is actually 4 unit, right? And the total diameter of the larger circle is 6, and up to this length is 1.5. So this length is 1.5. So total is 6 minus 4 plus this 1.5. So what we have got, 0.5. So we got this length, up to this length is 0.5, right? So this one is 0.5. So up to this length is 2.5. Why? Because up to this much is 0.5, and this is the diameter of the middle size circle. So this is 2 plus 0.5, so 2.5. Now this is N, and this is O, and this point, let's say C point, and obviously this is C prime. Anyways, now the triangle NCO, and as OC, this color is not up to the mark, so let's say this is O and C is parallel to AB, right? Indeed, at C point, a right angle triangle, there is a right angle, and OCN is a right angle triangle. Indeed, we can apply Pythagorean theorem. So ON square equals to NC square plus OC square. Now plug in the value. So what is the value of ON? That is 3.5 whole square. NC is 2.5 whole square. 2.5 whole square plus OC is Y. So this is Y square. So Y equals to square root of 3.5 whole square minus 2.5 whole square. Careful here, most of the students make a mistake here. Sometimes they are written actually here 1 is square root of 1. because this is 3.5 and 2.5. So this is actually not only 3.5 and 2.5. This is actually 3.5 whole square and 2.5 whole square. Indeed, what we have, square root of 6. Careful about this one. And this is length, that's why we only take the positive value, not the negative value. So the final touch, so this point is C prime and C, remember, so this is y. So what we have got, y equals to square root of 6, right? So a C prime is equals to square root of 6, and b to c prime is equals to square root of 24, right? So our main objective is to determine the value of AB. So AB is equals to BC prime plus AC prime. Now sum of this two value, which is square root of 24 plus square root of 6. And if we have a look on square root of 24, so we can write down 4 times 6 square root plus 6. So here we can write down 2 square root of 6 plus square root of 6. So here it will be 3 square root of 6. So the final value A to B is equals to 3 square root of 6 unit. So this is the final answer. Thank you.